Okay. Okay, cool. I'm ready to start.
Okay.
Okay. So, hi guys, welcome back from break. I hope you enjoyed that pair deck that we did. Before we jump into the activity, I just want to review our standard and objectives. Danielle, can you mic in for us and read those for us?
Sure. Given a rectangle, parallelogram, trapezoid, or regular polygon, describe the rotations and reflections that carry it onto itself. Students will be able to describe the transformations that carry a parallelogram, trapezoid, and pentagon onto themselves. They will be able to determine if a shape has rotational symmetry and or reflectional symmetry and justify their reasoning.
Awesome, thank you. So before we jump into our activity, I want to just review a few key points from the pair deck that we just finished. So we talked about two important vocabulary words. The first one is reflectional symmetry, and recall that this means a figure can be reflected over its line of symmetry and it'll look the exact same. So to illustrate that, I have this triangle right here with the points A, B, and C. And as you can see, we have a line going straight down the middle from A to the midpoint of C and B. So this is the line of symmetry, because if we had this triangle and we were to fold it in half, it would look the same on either side. And if we were to reflect it, come on, okay, there. If we were to reflect it over this line, it'll look the exact same. As we can see on the bottom, our vertices switched, or our points rather. So B and C just switched, but A stayed right where it is. The triangle looks the same. So this is what reflectional symmetry looks like. And then our other keyword was rotational symmetry, and this is when a figure can be rotated around its center point n degrees and look the exact same. So to do this, it's crucial that we rotate from the center point. If we were to rotate from a different point, then it's just rotating around that point. If it's from the center point, and if it has rotational symmetry, it will look the exact same. So to illustrate this one, again, we have our triangle A, B, and C. I'm going to rotate it 120 degrees. And this gives us the exact same triangle. It's just rotated 120 degrees clockwise. I could rotate it again and it would still keep looking like that, and a third time would bring us all the way back with 360 degrees. So with rotational symmetry, it needs to be less than 360 degrees. Any object, any figure can be rotated 360 degrees and will look the exact same. So this is not a unique property. It needs to be less than 360. Like with this triangle, it's 120 degrees. So now that we reviewed that, I want to jump into our activity. So before I put you into breakout rooms, I just want to go over the instructions. There are 3 different figures: parallelogram, trapezoid, and a pentagon. And so what we're going to do is who's ever in breakout room 1 is going to do figure 1, which is the parallelogram. Group 2 will work on the trapezoid, and group 3 on the pentagon. And each figure right below it are a couple questions I want you guys to answer. But so to do this, I want you to use the toolbar at the top of each figure. And the toolbar can help you draw the lines of symmetry. And then you can reflect over that line. You can also rotate using the toolbar. You can put a point in the center of the figure, and then you're able to rotate around it. I was able to narrow down your guys' toolbar, so you only have what you actually need to use. If you finish your figure, go ahead and jump to the other ones and just mess around with them, experiment with them. I want you guys to take note of any patterns you're seeing or any reasons why you think certain things are working and certain things aren't working. Because keep in mind, not every figure has both these types of symmetry. So with that being said, we're ready for the breakout rooms. And I'm going to be popping in and out to ask you guys some questions. So go ahead and log on to GeoGebra and type in that code. And then can we just go into the first breakout room? Uh-oh. Where am I? Uh-oh, it's just us.
Did you not see the thing?
I didn't get an option to click anything.
Okay, let's see. Can you see it now?
Mm-mm.
Mm-hmm. Like it says you're in room 1, but you're not joined. So you have to find the thing to click on. Like move your.
Oh, okay. I got it.
Oh.
And then you click on the dot in the middle, the point in the middle.
Hey guys.
And then it should give you a window to put in the degrees.
I'll have a dot in the middle.
How's it going?
Oh, put a dot in the middle.
Oh.
Start with that.
Okay.
Then.
I was like, where?
We're learning how to use the tools.
Someone else do that.
Yeah, it's okay. You guys can take a minute to explore the tools. Do you guys have any questions on how to use the tools?
Yeah, how do you use the tools? Someone can just show me, just a screen share. I can't get it to rotate.
Here, I'll share my screen.
Do you have it, Danielle?
I drew the dot and now it won't rotate.
Yeah.
So I drew the dot and then I clicked on this button, the rotate around point,
Yeah.
and I clicked back on my shape. Oh, and then it popped up.
Oh, okay.
Did you get it?
Yeah, that didn't
You got
happen. Okay, cool. Thank you.
Okay.
Yeah.
Did the rest of you get it?
Uh-huh.
Okay, cool. Do you guys have any other questions about how to work GeoGebra right now?
No.
No.
Okay, cool.
I got it.
I'll pop back in a little bit to see how it's going. I'm ready for room 2.
Use the toolbar. Let's see. Reflect figure over those lines.
Hey guys, how's it going?
Good.
Cool.
Hi.
Cool. Do you guys have any questions so far about how to work GeoGebra?
I think we got it.
Okay, cool. So what's that line that you guys drew right there?
The line of symmetry.
Awesome.
Minus.
Cool. Does the trapezoid have any other lines of symmetry?
I think so.
You're right. It wasn't a trick question. Don't worry.
I was like, nope.
Oh no, there's 7 more. No, I'm just kidding. That's the only one. So yeah, you guys look like you're off to a great start. I'll pop back in a little while.
Okay.
And then room 3.
Onto it.
What do you mean? How
Hey,
many
guys.
degrees?
So it would just be 360.
Yeah. That's why I was like, the question's too easy.
So you guys on the pentagon, who's ever sharing, do you mind scrolling up a little bit?
Yes.
Okay, perfect. So with the pentagon, with all the shapes, there's a way for us, if it has rotational symmetry, keep in mind there's a way for us to rotate it less than 360 degrees. So yes, if you rotate it 360 degrees, it will end up back on itself, but that's not a unique property. So I want you guys to, with the rotation button, which is the one that has like the little alpha A with like 3 dots around it on your toolbar. One over. Go one more over. That one. Yeah. Rotate around a point. So you can click on the figure first, just like anywhere on the figure.
Okay, I did.
Okay. And then, oh wait, actually first we need to put a point in the center. So, yeah, right there, put a point. Perfect. Now click the rotate, click the pentagon, and then click the K. And now you guys can start experimenting and find out if there's any sort of number of degrees that'll rotate it onto itself.
Oh,
I'll
this is neat.
give you a hint. There are options less than 360.
Thank you.
So yeah, I just want you
Thank
guys
you.
to keep experimenting. If you guys are able to figure it out, I want you to try to see the pattern that exists. So I'm going to pop back in a little while and see where you guys are at.
Okay,
And
thank
then,
you.
yeah, let's hop back to the first room.
Oh wow.
Hello.
And the trapezoid
Is
does not have it has one line of symmetry down the middle, right?
yeah, it does.
Yes.
Okay.
We're not. Are we supposed to go on to the next one, or are we supposed to stick with our one?
I was experimenting with it because I had finished the first one.
Yeah, if you guys finish the first one, definitely jump on to the second one or the third one and just kind of experiment with those for a few more minutes.
So how did you guys explain that the parallelogram didn't
Can we go
have
to the
lines of
next one?
symmetry? It just didn't?
Next one.
I think we would say like we were experimenting.
Hi.
Hello.
Hi.
So what were you guys able to do with your trapezoid?
Well, we saw that with this line of symmetry, we could fold it and then it just maps it to itself again.
Mm-hmm. Perfect. Were you able to rotate it onto itself?
Well,
Oh, wait. Hang on, really quick. Remember which point do we rotate around?
the center.
Yeah. So you're gonna have to do a point, yeah. Yeah, you can click the trapezoid and then click point G.
Oh. Okay.
Yeah, anywhere on the trapezoid. Yeah, there you go. Oops.
Well.
Well, that's something different.
GeoGebra is not my friend.
Okay, so anywhere in the trapezoid and then point G. There we go. Okay, yeah, and now you guys can start messing with it and see if it'll rotate. Do you guys think it'll be able to rotate onto itself?
No, not unless we do 360.
Mm-hmm.
360.
Okay, cool. Do you have any idea as to why that is?
It's not symmetric,
Mm-hmm.
right?
Yeah.
Okay.
So this, this property, this symmetry only works if the trapezoid, or if the figure, sorry, not the trapezoid, if the figure is a regular polygon. And so a trapezoid, even though this one's an isosceles trapezoid and it has symmetry, the angles are not congruent, so we're not able to do it. We can do it at 360, but like I said, that's not the rotational symmetry because it needs to be less than 360 degrees. So cool. I will let you guys keep messing around with it.
Thank you.
Yeah.
That was a good reminder.
Yeah, for sure. You guys are doing a good job.
Leah, you have 2 minutes.
Okay, can we pop back into the last room?
Which is that group? You have 3?
Yes.
People over.
Hi.
Hey, were you guys able to get it to rotate onto itself?
Yeah, we got 72 degrees.
Yes, perfect. How did you get 72 degrees?
Well, I'm thinking now that it's 360 divided by 5.
Mm-hmm. Exactly. Where did you get 5 from?
The lines of symmetry.
Okay, perfect. Yeah. It also would be the number of sides. Mm-hmm. So yeah, pentagon having 5 sides. So yeah, this is one of the key parts about rotational symmetry, is as long as the figure is regular and all the angles are congruent, you can do 360 divided by n, and that's how many degrees you can rotate it. And since you guys got 72, you can also rotate it 144 degrees, 216 degrees, and 288 degrees. And it'll work. So yeah. Cool. Good job, guys.
Thanks.
And then if there's any time left, Christina, we could bring everyone back.
Okay. So I'm going to close the room. Let's see.
Mm-hmm.
We have 40 seconds.
Oh, okay. That's probably the end of it then.
I feel you. This is cool. I like this.
Oh, wait, I could leave the breakout room. Bye, guys.